All right. Hello, everyone, and welcome to our Sprint 3 progress. We are Team Codesaurus, and today we'll be talking about the MVP that we built, and the name is Quest. It's a journey into the unknown, and the choice is up to you. Quest is an AI-powered interactive storytelling platform that empowers users to co-create stories, navigate plots, and escape into the narratives of the worlds tailored to their decisions. We'll move on to the agenda for today, and we'll talk about more of our progress in Sprint 3 in the following slides. So this will be our agenda for today, and we can start by introducing the team.
Hello, my name is Ayla.
Hi, I'm Clive Lewis, and I'm the developer and tester.
Hi, I'm Dhruv Joshi, and I'm the Scrum Master and the developer.
Hi, I'm Ranmay. I'm the developer and tester.
I am Dylan. I am the full stack developer.
Hello, I'm Farham Kademi. I am the team lead and also a developer on this team.
Hello again. I am Sharon D'Souza, and I am the full stack developer. So for the last sprint, we received no feedback for our progress because we did a great job. So we tried to continue to maintain that in the sprint as well. And we'll move on and handing it over.
So the problem that we're trying to solve with the platform that we're trying to create is trying to create something that helps people solve the limited flexibility in RPG games, which are role-playing games. And also at times there's lack of imagination and creative inspiration during creatives like storytelling or trying to build games. And also sometimes realization of stories that lives in your mind, you want to kind of bring them to life. And we are trying to create a platform that kind of helps you achieve that. We also trying to have effective ways to work through creative blocks. So we developed Quest that tackles these challenges using an AI-driven narrator. So our solution compared to existing solutions is different in a way that we kind of give the user the option to have unlimited choices. There's been other platforms such as Zork that when you're playing the game, they give you a context and give you a bunch of options where you choose from. But our story goes where the context is generated, but we um, the user can type a response to it. Now there is an application similar to it. It's called AI Dungeon, where they do the same thing, but ours is different because we have more enhanced immersion in terms of there's going to be visuals as you're playing the game, and you can see the NPC portraits and the enemy portraits as you're playing the game. And we also have a multiplayer option, which AI Dungeon does not have. And we are looking to have more accessibility features. And a quick uh, view of the project description. You can go next. Go to the next slide. It's okay. Yeah, so this is a quick brief view of the project description. It's technically everything I described earlier, where we are trying to create a platform that is an AI-driven interactive novel that allows users to dive into a thrilling world of imagination intended to blend compelling storytelling with player agency. It also allows the readers to shape the narrative by making choices that directly impact the story's progression. And these choices can influence character relationships, they can change story outcomes, provoke ethical dilemmas, and also unlock secret plots. And that is how you win the game. So, um, with that, can move to the next slide. So, yeah, Clive, could you please? Yes.
So, yeah, this is how we set up our team working agreement at the start of all our sprints. And some major points that I would like to focus about was mainly we communicated over Zoom and uh, had our code managed to GitHub and maintain most of our documents in a Google Workspace account. We also made sure that every member felt that they can express their concerns clearly. We also had meetings twice a week, every Sunday and Tuesday, and tried to have a fixed agenda for each meeting. And each meeting at the end of the sprint was a retrospective, which was recorded separately. Talking about the team dynamics and principles, major points included having Jira trackers updated regularly, made sure that every team member understands their responsibilities and tasks clearly. And when it comes to on the right side, we can clearly see what we consider to each task to be as completed. We make sure that all these accomplishments were completed so that we can say that a particular task is complete.
All right, so moving on to the user personas for our MVP. We've narrowed down our potential user base and summed them up into these personas. The first is the reader. So this is Betty Thompson. And this type of user is someone that is seeking a quick yet meaningful getaway or longs for stories that can be experienced on their own terms, with the ability to rewrite the outcomes and ask the eternal question of what if? What if the princess didn't kiss the frog? What if Romeo and Juliet did end up together? And so on and so forth. Quest proves to be a solution because it lets users play these preset stories and interact with them in their own unique way. The next user persona is the novelist. This is John Alwyn, and this type of user is anyone in the creative space experiencing creative blocks who often finds it difficult to express and explore complex storylines without external judgment or overwhelming tools. Quest proves to be a solution by giving creative writers the space and puts them in the driver's seat of decision making and to interact with their own story, and also lets them have control over their own work without the worry of theft or plagiarism. The next persona we have is the gamer persona. This is Jason Bourne, the type of user that faces frustration with existing platforms as they fall short in providing a level of emotional and narrative flexibility, often offering limited customization and only single player formats for the games. Quest proves to be a solution by introducing unique storylines for every game that the user can play, no matter how many times it is repeated or how many times the same story is played out the same way, the outcome will never remain the same. And Quest also introduces multiplayer agency. Yeah, I'm moving it forward.
So to kind of introduce our MVP, we're trying to create an AI-driven interactive novel that has visual elements, and these visual elements are presented as the portraits of the non-playable characters that appear throughout the story. So yeah, these are some of the non-playable characters that we've included in the stories, and these are specific to each story. So the MVP that we have is going to have dynamic narratives, meaning that the users, based on their input, can shape the story however they want. So the replay value is high because each game is going to be very different. We also have choice systems that help so users can type actions to interact with the context. They don't have limited options to choose from. There's going to be visual elements, which are the non-playable characters' portraits. There's also a simple UI, which makes it very intuitive to use the application, to use all the features that there are available for the users. And also, this we did not add this feature yet, and it's going to be decided when we add the user account system for it. I'll be passing it on to Drew.
So the tech stack that we have decided for this entire project is we would be developing our front end on React and JS, back end on Node.js, Express.js, and ChatGPT's Open API. ChatGPT's API. The databases will be using MongoDB, and we are planning on adding AWS as well for multiple storages of devices of images for NPCs and stuff. So we will be getting a final decision on that. And tools, we are using Jira, GitHub, Slack, and Visual Studio Code for our ease. So describing the front end, we went with React because React provides a very stable, very easy to approach standard that the market follows for developing front end, where we have a lot of features that we can introduce uh, with a good community support. Backend, we went with Express.js because it ties in very neatly with React as a front end, and it is a very flexible and lightweight framework so that we would not be losing a lot on computational costs as well. Database, we are going with MongoDB because it is, of course, flexible. Being a NoSQL database, we can store JSON-like structure so that we can scale it horizontally as big as we want it to be. And it is rich in querying and indexing features, as the return times for MongoDB servers are very fantastic compared to others. Tools, Visual Studio Code, of course, for coding, GitHub for code management, Jira enables us to track all of the stories and bring out metrics like burn down charts, have story completions, and etc. Together, they streamline our entire development workflow, and the way we approached this project was greatly influenced by these three major tools that we used. Components. So our major in a theoretical way, all of the stories that we took up were divided into these four components in our project. One being the player status manager, where all of the stories which are related to keeping track of the player, keeping where the player is in the story or what it is, what the player is interacting, is under player status manager. Game status manager manages the game, the sessions, the AI narrations. AI LLM model manager is the interaction between the ChatGPT's AI model and our own backend. And the prompt generator helps us defend against prompt injections, query injections, and other such vulnerabilities that people might try to exploit. So the project schedule that we had set up was for Sprint Zero. We decided on the MVP, decided on the tech stack, set up the tools for tasks, set up our Jira, set up our GitHub accounts, etc. For Sprint 1, we were mainly focused on building the base of the code, that is, get the narration and the interaction between user and AI down so that we can start building around it. Then for Sprint 2, we started adding the theme page, the character page, the story page, what would go on before the story, how are we approaching the end of the story, the dice roll, and other such bells and whistles. And for Sprint 3, our major focus was to get our accessibility down, where we had text to speech and speech to text introduced, multiplayer introduced in the game, and other such features that we'll be talking about later in this presentation.
Okay, so now we'll start with architecture diagram. Here the user will be communicating with front end, where we're using React in there. This is where all information will be taken from the user and begin communicating with the back. The back that's in Express and Node from the other side is going to use the database and the narrator to create the interactive novel and present it to the front end for the user. And this will be all for the architecture diagram.
Hi. So in the ER diagram, we're talking about the many relationships. For one-to-many, there's theme to stories, where one theme can have multiple stories associated with it, which is indicated by the line connecting theme ID and themes to theme ID and stories. Then there's stories to game session, where one story can have multiple game sessions played based on it, which is indicated by the line connecting story ID and stories to story ID and game session. Then there's game session to logs, where one game session can have multiple log entries, which is indicated by the line connecting game session ID and game session to session ID and logs. Then there's NPCs to stories, where one NPC can be associated with multiple stories, which is indicated by the line connecting NPC ID and NPCs to NPC ID and stories. Then lastly, there's characters to game session, where one character can be played in multiple game sessions, which is indicated by the line connecting character ID and characters to character ID in game session. And that's all for the ER diagram.
So, talking about the context diagram, where we have the initial user firstly interacting with the theme selection screen, where he selects the appropriate theme for the story and which is sent through the game window screen to a central engine, which begins the game session. The game window screen is mainly meant for the user to interact and send their responses as the story progresses. And we would have the responses from the user thrown to a central engine, that is the quest engine at the center, which would respectively throw the logs to the MongoDB database and get the appropriate response based on our setup prompts from the OpenAI model. And that's how the back and forth interaction between the game window screen and quest would take place until it reaches the end of the game.
Yeah, so I'll be talking about the sequence diagram. This will run you through how the application is working on the flow of the application on the tech side. So this diagram talks about this how shows the flow when a player starts a new game. It begins with the player selecting a new game, which triggers the front end to fetch available themes from the back end. Once themes have been retrieved and displayed, the player picks a theme and the relevant stories are loaded. After the player selects the story and enters character details, the front end sends a post request to start the game. The backend here creates a session, saves the character, and retrieves the selected story from the database. Once everything is ready, it returns the session ID and the initial story state, which is then displayed to the player. From this point onwards, the session ID is used with every interaction to maintain continuity. Next slide. So this sequence diagram is talking about the flow for the player choices within the game. It covers the flow of player choices during an active game session. When a player enters a choice, the front end sends that choice to the back end along with the session ID in order for it to process the next narration. The back end stores that choice along with the previous narrator progression in the database as a new log. Then it retrieves all the past logs for context and sends them to the AI narrator, in this case OpenAI, to generate the next part of the story. The narrator returns the next progression, which is stored again in the database and finally sent back to the player as an updated story. This loop continues as long as the game is still in session. Next slide. So this is a continuation of play choices. It extends the play choice flow to include dice roll when required. Just like before, the player enters a choice and the backend logs it, retrieves the past session data, and asks the narrator to generate the next part of the story. But the twist here is that if the action involves any sort of uncertainty or risk, the narrator also returns a dice threshold, prompting the front end to show a dice roll option. When the player clicks the roll button, a new API call is made. The backend rolls a dice, stores the result, and again consults the AI, this time to decide the outcome based on the result of your dice roll, whether it has passed or failed the required threshold. The narrator then sends feedback to the backend, which stores it in the database accordingly. Next slide. This sequence diagram is to show manual endgame. This is pretty straightforward. Whenever the player decides to end the game halfway through, it sends a post API endgame call to the backend, which marks the session as completed on the database and sends an appropriate message back to the front end, where the front end promptly deletes the session ID so that it can no longer be played and returns an appropriate message. Next slide. Yeah, this sequence diagram shows how the game ends. The player makes a final choice, which is sent to the backend just like the previous turns. The backend logs the input, fetches the full session history, and forwards everything to the AI narrator. The narrator then checks whether the story conditions match any of the endgame rules. If so, it sends the final narration back to the backend, and the backend marks the game as end game, similar to manual. This is saved and returned to the front end eventually, and that at that point the backend deletes the session ID to backend and front end deletes the session ID to wrap up things, and the final message is displayed to the player whether you won or you lost. Yeah.
So I'll be recapping the sprint one that we had. So as I mentioned earlier, the sprint one was mainly involved with the core of the entire project, that is developing the AI and the user's interaction part, the game session page. Because if we had that particular page down, we can start building around it. So in a similar fashion, all of the stories that I have shown revolves around that interaction, and we also started preemptively to build up theme pages and the story pages and the character creation pages, so we can set a foundation of these and nail it down properly. So these are the test cases, and one story, that is US-07, was carried over to Sprint 2. That is for the reading of the created story. Sprint 2, I'll hand it over.
Okay, so the sprint 2 recap goes as follows. These are the user stories which were involved in the sprint. And next slide, please. These are the test cases which were completed, and then US 10, which was carried on to the next sprint, which is sprint 3. And then the product backlog, which was done, customized as such. This is the product backlog for the sprint 2 and then sprint 3. Handing
Okay.
it over.
Yeah. So I'll quickly go over the Sprint 3 backlog. For the Sprint 3 backlog, it's a little bit modified than the previous product backlog. That is because in this sprint, we had to carry over two of the previous user stories from the prior sprints, which were I think the user story 14 and user story 10. And with these, we managed to complete majority of them, but did leave one optional user 17 to be left if we would be able to finish all the other user stories. But with the limited time that we had, we kept this one for the future projects.
So, talking about US10, the main purpose of the story revolved around reaching a conclusive end to the game. We worked a lot on this in the previous sprint and had one particular test case which failed, which was getting a clear, conclusive message. This is the first test case in itself. And working on it on this particular sprint, we were able to clear that one as well, and hence we get a clear indication of when the game ends in each scenario, such that we have a conclusive end for each game.
So for this user story, the test was mostly within the front end, like to see when the user can go into it, they can see the number of players being played. So they can launch the game, reach to the character description page and click the add button and add the number of players that are going to be involved in the story. And these are the players that can play the game alongside with the protagonist, not the non-playable characters. And the expectation is that they can intuitively recognize the multiplayer option. And the actual result is as followed. They were able to do it and pass. They clicked the button and they could see the number of characters. This was tested by Dylan. And yeah, the selecting the number of players. This is the adding option where they click the add button and they see the number of players. And lastly is to prevent the game to start with just a single, like to prevent the game to start without any protagonist in it. So this would work by as you're removing the number of players that are involved in the game. When you reach the first player, only when you're on one player, the delete button would be grayed out, so technically disabled. And this way, you could not you could not reduce the number to 0. So this passed, and this also was tested by Dylan.
Okay, so for this user story, we tested out two sections. We start out with the microphone button. Here the user loads the game in a modern browser and just clicks talk to the game. The test confirms that speech recognition is successfully activated and captures whatever the players speak out loud. And as we can see here, this test is passed. And for the second one, the player clicks the play story button after loading the game. The browser then uses speech synthesis to audibly read a portion of the story, and the player in natural voice. And that's it. The output matched the expectations here, and this test is also passed.
Yeah, so this user story mainly involves the multiplayer setting where the narrator will now have to determine the next story progression based on multiple user inputs. So the following test cases were run, adding additional players before starting a game and handling it. So all of these were tested by Isla. So you could add the test was you could add multiple players to play the game, and that was successful. The story updates after each player's input. So the narrator successfully takes into account everyone's input and generates a story progression. And the last one is dice roll is triggered as a shared and universal action. So whenever a dice roll dice roll is required, the UI switches to a singular input, meaning all user inputs are acted as one dice roll, and all of these passed. The next user story is to determine which players go. So all of these were tested by Clive. So when you open the game session page, all the characters that you have created should show respectively on the front end. This was properly incorporated, and you could switch between players. All players can input simultaneously. So each player had an option to enter their own input for their character. This was done and passed successfully. And player selection is optional. So if out of 3 players, 1 player did not want to give any input for this current narration, they could do so by leaving it blank, and the story progressed as needed and was successful.
So this user story is the user story that allows the user to see the visual graphics as they're playing the game. So for us, this was to present NPC portraits anytime the player is in close proximity to another non-playable character that is in the story. So the test case title is the NPC images are shown when mentioned in a context. So you start the game and start looking around for NPCs, non-playable characters, and as they appear in the context, their portraits will pop or appear under the context and show you that right now you're in close proximity to, for example, like Elder Soren, and you can start interacting with them. And even if you run away, try to say like, I'm walking to a far distance, that I'm not close proximity to this non-playable character, the portrait will disappear. So making it much more immersive than just pure text. So the expected result was so that the players appear as they're mentioned throughout the context, and the actual result was that whenever they were mentioned, they did appear as their portrait under the context mentioned. This passed, and this was also tested by Dylan.
Yeah, so I will briefly run through the stories completed. For sprint 3, we focus mainly on multiplayer and speech to text as well as text to speech. There was an additional user story that we took up, but we predicted that it might not be able to be done but we did want to focus on the other topics mainly, and that was US 17. As you can see, it was not completed because of the complexity of other user stories. Next slide. These are the other user stories that have been completed. Next slide. And this shows neatly which ones were completed and which ones are not. As said, user story 17, was predicted to not complete, and hence it wasn't.
So for the sprint 3, we have relatively performed very well from all of the documented sprints, as we were able to get 45 points across the line, as we had committed for 45 and the rest was an uncommitted but optional story that we took on. So that makes our average across 3 sprints to be 37. So the committed to completed ratio can be visualized over here, where we also average out to 83% for the committed stories that we took up and we completed those.
Sorry, real quick, I have to connect my charger. But this is the burnt down chart for our sprint 3. So as you can see in the beginning, the progress was kind of, we didn't do much in the beginning. That was because of the fact that the previous sprint, we just finished the previous sprint and we had a lot of work in the previous one. And we had to get our documentations ready. And with the planning, this kind of made us wait on the starting the implementation. But when we did start the implementations, we did start with the higher story points, which helped us complete 34 story points by the first progress area. Then after that, then people started to completing their story points, where we can see that there is a little bit more of a downward cycle, and then towards the end it falls, and we're almost done with all the story points. But as you can see, it doesn't reach the end, and that is because we decided to conclude the user stories and the project one day early, and that is due to the fact that we have a lot of academic documentations that we have to provide, which is slowing us down on the fact that we can't provide all the user stories for this sprint. But with that, we were able to complete more than 90% of our user stories.
So, yeah, I will talk about Sprint 3 retrospective. So let's start off with what went well. What went well, all members were familiar with the tech stack, as they should be. This is Sprint 3. Frequent stand-ups helped us stay in sync. That means no one went MIA this time. Deadlines and code freeze were well respected, so no one broke code at the 11th hour, and we didn't have to scramble for fixing things. Peer programming improved collaboration. I feel that's self-explanatory. Like, without peer programming, I don't think the quality of the code would be this good. Documentation workload did not hinder commits. As said before, there was a lot of documentation for this sprint as compared to other sprints, and somehow that did not hinder any of our timelines. So yeah, that is for what went well. What could be improved, and there's always things we can improve on. Be more mindful of committing message. Like, we don't need final real fix commit messages anymore. Code standards need to be clearly followed. That I think is again self-explanatory. Use proper variable names, proper commit messages, proper comments, etc., etc. Avoid duplicate packages and dependency. I think right now our package.json looks like it has a hoarding problem and clearly needs an intervention. Old features should not be removed without discussion. Well, again, we should make sure that when we have merge conflicts, that we resolve them properly and do not get rid of features that have been committed from other sprints. Our commitments, we look forward to using Gitflow branches more. Initially, we only used a bare bones version of Gitflow, but now we look forward to setting up QA branches, hotfix branches, release branches, and so on, because the project has gotten much larger. Then discuss component structure and development, component structure before development begins, because we don't want to rebuild components midway. and establish and follow code standards. Well, yeah, we should really talk about our code standards because everyone has a different way of naming variables, different style of writing commit messages, and it'll look a lot neater if everyone did it the same way. That is all. Yeah, so the project demo, these are a few screenshots which you will see during the actual live demo, but this is the theme selection page. Yes, you can go next, it's fine. This is when you select a story, you see the beautiful NPCs on the side. Next slide. This is the character creation page, which has been updated to handle multiplayer. Next slide. And this is the game session page that has been updated to include multiple players.
All right, so coming to the API documentation, this is the theme and story preset APIs. These are the APIs that have to do with fetching all the themes, viewing all the themes, where the user interacts with the app in its initial stages, picks a theme, and then picks a story within that theme to move it forward to create their own character.
So the character APIs, the character creations routes have post and get where we can upload a character and get the characters. Now the get function is more of just an ease of access to see what is going on in our backend and get character by name. This is also just a debugging function that I have kept in the APIs so that it is just ease of access and in later use if we want to use it again.
These are the game session APIs. We have a mixture of post and get requests. The start game API that will require which story you're playing. The play turn post API which will require with the player choices. Get game state is just to fetch all the logs to display on the game session page. Manual endgame is for when the user wants to end the game midway. In that case, they'll have to send the particular session ID so the backend knows which one to end. And get player choices again is just for displaying it on the front end.
So this is the logs API. This is where the memory retention happens within the narrator. So there's to create the logs, we using the post where it saves all the logs by the session ID. It also takes account into the dice roll and also the users that are in the scene during that iteration. Then there's also the second API call, which is the fetch log transaction by session ID by the sessions, which gets the logs based on their session ID. And it has all the information such as the NPCs that were in scene during each iteration and also the results of the dice roll, along with the context and the user input. And this itself allows the narrator to have awareness of and have logical continuity. So you can go next.
This is the dice roll API, which is only available when the narrator requests a certain dice roll action from the front end. When the user clicks the dice roll button on the front end, it sends a message to the backend to generate a dice roll and return the next generation of the story. Next. Yeah, this is the NPC APIs. We have created a few NPC APIs for an admin to create NPCs. That's the post one for /admin/NPC, where it sends the NPC details and saves it to a particular story. Then view all NPCs just gets all the NPCs from the database, and admin upload NPC image, which takes takes an image from the front end and stores it for a particular NPC on the S3 bucket.
Okay, so the voice APIs, we have two endpoints here as well. The first one, voice input, is a post request that will basically receive a spoken audio file forwarded to the OpenAI Whisper that we have used. and then later on to transcribe the speech into text and return the actual transcript. And then the second one, the story playback. This is also a post request type. Will convert a given input text that the player will execute into natural speech using the OpenAI text to speech and returns the audio for playback. And the next slide is the wiki page link. And can you go back so we can show the wiki page? Sorry.
That's
So as always, we start with our project description. You can scroll. So we have all of our team members presented here. And then the brainstorm design, the languages and tools that we also presented before. All of our diagrams will be here, and then if we click in each of them, we'll direct you to the exact diagram. Yeah, you can scroll, it's fine. Yeah, we have the deliverable, the user story and acceptance criterias. Then we have all of our recordings, PDF files, and all the retrospective videos here, organized sprint-wise. The sprint 3 will upload for sure after we finish all the documentation. We have the team working agreement, and then in the end, the product personas. This is the wiki page.
Yeah, I will continue with the application demo. Just going to share screen. Can you guys see my screen?
Yes.
So this is the landing page that you'll be greeted with when you open Quest. Very wow, very beautiful. These are the themes that hold all the stories. So for this case, I'm going to do Dark Forest. This is the only story that is available in Dark Forest, Whispers in the Dark. Here you get to see beautiful NPCs, handsome NPCs. I'll go ahead and create 2 characters to demo multiplayer as well. All of Demand Money is here. Let's former I'll add another character. Let's do Fairy Cake. Race Demi Dolphin. Class. Let's go Wizard. Background. Former Prince of the Imperial Army of the South. I don't know how a prince is part of the army, but sure. Strength 10, aka 10. No, the dolphin has wings. 10, intelligence 9, wisdom 1. I joke. There is no 10. And go on. Continue. Here the story begins. The adventure begins and everything. Here we can select which player wants to go. So if Fairy Cake goes.
The adventure begins. Voice whispers your name
Can you guys hear that?
darkness ahead,
Yeah.
but you can't tell if it's a
Yeah, we
spirit,
can hear that.
trap, or guide. The path forks, one leading deeper into the forest and the other back toward the edge of the woods. What do you do?
So immersive. Ooh. Yeah. Fairy Cake. What does Fairy Cake want to do? I take a look at my surroundings and take a minute to smell the flowers. Demon Monkey, as your bard, I break into dance and song. The narrator is thinking very hard, as you can see. Oh, look, it's Elder Sorin appeared. And as you can see, let me actually get them to speak for you.
Berry Cake, your keen wizardly senses take in the surroundings as you pause to appreciate the aroma of the flowers. Nearby, D-Man Monkey, the robust warrior, breaks into an enthusiastic dance, punctuating the forest's tranquility with his hearty song. Suddenly, from the shadows, Elder Soren steps forward, a soft smile on his face as he watches the spectacle. What do you do next?
As you can see, the narration is quite adaptive to any context that you give it. It can also handle different classes of characters that you give, as normal um, visual novels will not be able to handle demi-human, demi-dolphin, half human, and so on. This is all for the application demo. I'll just quickly reshare to show you a bit of the code. Is VS Code? Yeah. Again, can you guys see my screen?
Yeah, we can see it.
So I'm only going to show you some of narrator controller as well as a little bit of the front end. The rest of the code can be found on GitHub. So here's the start game endpoint where the user sends the story ID and the characters that it is going to play with. The backend fetches that story, gets all the details, ensures that the amount of characters inputted is less than the max amount of players, then creates the game session, characters, links them, and creates the initial log. The play turn API was explained before, but it basically takes the session ID and the player choices as an array, sends this to through process narration, which is connected to OpenAI, and gets back the response, sends it to the user. Process narration is basically it takes the NPC list, cleans out the most of the code given by either play turn or dice roll, and sends it to a way that the narrator can understand and give back the appropriate messages. So that is for the backend. That's all I'm showing. And for the front end, I will just show app.js where we have our routes, the landing page, the themes page, the stories page, character page, game session page, and the chat window. Yeah, I think that is all. We expected a footer initially, but I guess we can live without it. That is all.
So I think with that, we can officially conclude our final meeting. It was great working with all of you. I hope we can work on future projects all together. So for the last time, Coach Saris is out. Have a good night, everybody.
Thank you.
Thank you. Good night.
Good
Thank
night.
you.